So both of these are kind of tough problems. The first one up here, we have the multiple in parentheses. Now, as we mentioned last class, when we have more than one thing to do at the same level of priority, we work left to right. So our first parentheses is right here, and we have to find its other end, which is way down here. So we begin by focusing inside that blue box, the parentheses there. But inside there, order of operations still applies. So we find the next set of enclosing symbols, which is this one, and we find its other end, which is down here. Well, inside that set of parentheses, inside the green box now, our order of operations still applies. So we keep going, and we get into this set of parentheses, another set of enclosing symbols. So we're going to narrow our view down to that set of parentheses inside the purple box. In there are no other enclosing symbols, so we move down the list of priority. Exponents, we do have 3 squared. Now I'm going to cheat. I'm going to erase the 3 squared and put in 9. So no more exponents, so we move down the list. Multiplication and division is not there. Addition and subtraction, we have 9 plus 3, which is 12. So I take out the 9 plus 3 and replace it with 12. Now, as we mentioned last class, once we've reduced an enclosing symbol to a single number, we don't need the enclosing symbol anymore. These are just parentheses, so I can take them out. I don't have to do an operation when I get rid of it. And there is a symbol, an operation, in front of the parentheses, so I don't have to put in multiplication or anything like that. So now I move back out to the green box, the larger set of parentheses. 36 divided by 12 is 3. So now I've reduced that set of parentheses to a single number. I don't need that set of parentheses, so I take them out. Now again, there's an operation on both sides of that set of parentheses, so I do not need to put in multiplication. So now we're back out to the blue box, the bigger set of parentheses, and in there we're still going through our levels of priority yet. So we're back up to the top level, enclosing symbols, and we do have an enclosing symbol. We have another set of parentheses. In there then, there's no enclosing symbols, so we move down the priority, no exponents, no multiplication or addition or division. We do have addition and subtraction. 5 plus 4, which is 9. Now we've reduced that parentheses to a single number, so we can take it out. This time, however, we do have a number in front of the parentheses with no operation. So what do we have to put in there? Multiply, right? Now we're back out to the blue box, the big set of parentheses. Going through our levels, no more enclosing symbols, no exponents. There is a multiplication here, 2 times 9, which is 18. And then we're no more multiplication, so we're down to addition and subtraction, so we're going to work left to right. 9 minus 3, or 19 minus 3 is 16. 16 minus 18 is a negative 2. Negative 2 minus 2 is a negative 4. So now I don't need, reduce that set of parentheses down to a single number. So I don't need it as an enclosing symbol, but because there's a negative 4 in there, I am going to leave it there. So this is now 8 plus 3 times negative 4 plus the 3. So this parentheses is no longer being used as an enclosing symbol. It's just being used to isolate the negative 4. Now we have the multiplication, 3 times negative 4, which is negative 12. So replace the 3 times 4 with negative 12. 8 plus negative 12 is a negative 4, plus 3 is negative 1. Show of hands, how many of you got negative 1 for that? A couple of you? That is a tough one. That was a long one. Moving down here for number 2, anybody want to share what they got for an answer? Nobody wants to be brave? I promise I won't laugh. Okay, well, we've got the top here. The fraction bar across here is an enclosing symbol. It's telling us we have to do everything on top first. So let's do everything on top. So on top, no more enclosing symbols, but we do have an exponent. 5 squared is 25. Next, for multiplication, 7 times 3 is 21. 21 plus 25 is 46. Plus 2 makes 48. So the top of that is 48. On bottom, now the square root is an enclosing symbol, but that's all that was on bottom anyway, so we have to do everything inside the square root first. Inside there we have the exponent. 3 squared is 9. Then we have the multiplication. 7 times 9 is 63. And 63 plus 1 is 64. And as always, we've got what's inside of an enclosing symbol reduced to a single number. It's time to eliminate the enclosing symbol. Unlike a parentheses, we actually have to do something here. So what is the square root of 64? 8. So we have 48 over 8. That divides. 48 divided by 8 is 6. Good. Okay. And over the next couple of days, I plan on coming back and reviewing some of that stuff as we go through, because your first test is coming up. Depending on how the next couple of days go, it looks like it should be at the very latest Wednesday of next week, possibly Monday of next week, but we'll see how that works out. Okay, so for our topic today, our new topic, we're going to be looking at percents. Continuing a little bit with our review of arithmetic. Dealing with percents. To understand a percent, it's vital to understand the word percent. And it's actually 2 words. There's per, if you think of miles per hour, miles per gallon, dollars per hour, which can be thought of as for each or out of. And cent or cents, if you think of years in a century or cents in a dollar, that is 100. So the word percent literally means out of 100. So if we have 68%, that literally means 68 out of 100. In fact, that percent symbol here that we're used to seeing like that actually came from that symbol right there. Is a symbol for a generic ratio. Percent is just a standard ratio that's out of 100. So it is actually just this simple to turn a percent into a fraction. 68% is 68 over 100. Now, of course, we're not going to leave it as 68 over 100. We can reduce it because both of those can be divided by what number? I heard somebody whisper it there. 4. Good. 68 divided by 4 is 17. What's 100 divided by 4? 25. Good. So 17/25 is 68% expressed as a fraction. So 40%, similarly, would be 40 over 100. And we can reduce that one. What can both of those numbers be divided by? Both 40 and 100 can be divided by 10, or they can be divided by 20. Could have divided by 10 and then by 2 would have worked as well. 40 divided by 20 is 2. 100 divided by 20 is 5. It's 2/5. Well, it gets a little more difficult. We can run into 235%. Now, a lot of people mess up here and they want to put extra zeros in here. But percent is always out of 100. 235% is 235 out of 100. Now, people might be saying, well, that's an improper fraction. It's bigger than 1. But you have to remember, 100% equals 1. 100% is a whole thing. So 235% is bigger than 100%. It will be bigger than 1. So this is going to be a fraction bigger than 1. Now, 235 over 100, the next thing I would do is split it down into that mixed number. 100 goes into 235 twice. If I take 200 out of 235, I'm left with 35 over 100. And now I can reduce the fraction. What can I divide both 35 and 100 by? 5. Perfect. Now, don't forget, I still got the 2 there. 35 divided by 5 is 7. 100 divided by 5 is 20. So 2 and 7 20ths. We might have something like 36 2/3%. Now, again, it doesn't matter that that's a fraction. A percent is always out of 100. So that is 36 2/3 out of 100. Now, there are two different ways we can approach this. We can either think of common denominators. I don't know if you've ever solved equations with fractions, and one of the strategy is find a common denominator and multiply the whole thing by a common denominator. So that's one of the possibilities here. Well, the only fraction we have is the 2/3, so our only denominator is the 3. So I can multiply the top and bottom of this by 3. Well, the bottom's easy. 100 times 3 is 300. On top, we're going to have to do a little bit more work. We have to turn the 3 and 2/3, or 36 2/3 into an improper fraction. So 36 times 2 is 108, or 36 times 3, I should say, is 108, plus 2 is 110. So that's 110 over 3. Now we're multiplying by 3. I'm going to make that a fraction by making it 3 over 1. And now we can cross cancel the 3's. We'll divide out to be 1 and 1. So 110 times 1 is 110. 1 times 1 is just 1. So that is 110 there. So we now have 110 over 300. Of course, that can be reduced. Both can be divided by 10. 110 divided by 10 is 11. 300 divided by 10 is 30. So 36 2/3% is the same as 11 out of 30. We can also run into something like this, 56.25%. Well, again, every percent is out of 100. So that is 56.25 out of 100. Now, we don't like having decimals within our fractions any more than we liked having a fraction within our fractions. So to get rid of that decimal, the only thing we can really do with a fraction is we can multiply or divide both the numerator and denominator by the same thing. So here, since that is a 0.25, you might see that you can multiply by 4 to get rid of the decimal. But you might not always see that. The easiest way to do it is just this. There are 2 decimal places here. So to get rid of the decimal, I multiply by 100. If there were 1 decimal place, I can multiply by 10. 3 decimal places, I can multiply by 1,000. That gets rid of the decimals. So if I multiply the numerator by 100, I have to multiply the denominator by 100. 56.25 times 100 is 5,625. 100 times 100 is 10,000. Now we can reduce these. Can anybody tell me what is the largest number that goes into both of those? I'm sure you can see the 5, maybe the 25. Can anybody see anything larger? Let's do the 25 for you. So if I do 25, that's going to be 225. 5,625 divided by 25 is 225. 10,000 divided by 25 is 400. So now we have 225 over 400. Both of those can still be divided by 5, but I'm going to go one step up. I can still divide both of them by 25. 225 divided by 25 is 9. 400 divided by 25 is 16. So 56.25% is 9 out of 16. In your notes, quick, I want you guys to all try a few. So I'm going to have you do 484%. Change that into a fraction. I'm going to have you do 18 1/3%. Change that into a fraction. And 62.5%. Change that into a fraction. We'll talk about those in just... So for the first one here, 484% is 484 over 100. So 100 goes into 484 4 times with 84 left over. 84 and 100 can both be divided by 4. So I've still got the 4 whole number here. 84 divided by 4 is 21. 100 divided by 4 is 25. So 4 and 21 over 25. 18 1/3% is 18 1/3 over 100. Multiplying by 3 is one thing we could do because it's 1/3. I'm going to do a different method since I didn't show you that one. I forgot to do it here. The other method we could do other than multiplying by 3 on top and bottom to get rid of the fraction is to just treat the fraction as division. 18 1/3 over 100 can be thought of as 18 1/3 divided by 100. And it's basically the same process we went through when we multiplied by 3 on top and bottom. 18 times 3 is 54, plus 1 is 55/3. Treat this as 100 over 1. So instead of dividing by 100 over 1, we're going to multiply by 1 over 100. 55 and 100 both can be reduced by 5. 55 divided by 5 is 11. 100 divided by 5 is 20. So 11 times 1 is 11. 3 times 20 is 60. Show of hands, how many of you had 11/60ths for that one? Not too bad. Okay. And then the 62.5%. That is 62.5 over 100. What are we going to multiply by to get rid of the decimal? 10. Good. One decimal place, so we multiply by 10. So that is now 625 over 1,000. Both of those can be divided by 5. Both can even be divided by 25. They can be divided by 125. Again, if you divide it by 5 over and over again, you'll get there too. 625 divided by 125 is 5. 1,000 divided by 125 is 8. That is 5/8. So we can convert percents into fractions easy enough. Converting a percent into a decimal. We've already said that 68% is 68 over 100. To turn a fraction into a decimal, we just divide it out. 68 divided by 100 is 0.68. So changing these percents into decimals, it's always going to be dividing by 100. And when you divide by 100, all it does is takes the decimal point and moves it 2 spots to the left. So if I have 41%, what is it going to be as a decimal? Go ahead and yell it out. Move the decimal point 2 spots, it becomes 0.41. There we go. Somebody started to say it. If I have 90%, what's that going to become as a decimal? 0.9, good. How about 7%? 0.07. 260%. 2.60 or 2.6, either one would be fine. 5.9%. There you go. You have to move over 2 spots, so it becomes 0.059. Here's the tricky one. 1/4%, what's that become as a decimal? A lot of people want to say 0.25, but remember, 1/4 and 0.25 are the same number, so it's still 0.25%. We have to move the decimal point over 2 spots. So that becomes 0.0025 as a decimal. When I deal with percents, I talk a lot about something called benchmarks. And one easy benchmark is 1%. 1% as a decimal is 0.01. So for 1/4%, if I just think of the 1%, I know that 1/4 is smaller than 1. So 1/4% has to be smaller than 1%. So whatever I get for a decimal for 1/4% has to be smaller than the decimal for 1%. So it has to be smaller than 0.01. So if I get 0.25, I know that can't be right because it has to be smaller than the decimal for 1%. Now, if I'm going to go back the other direction, if I have a decimal and I want to turn it back into a percent, a decimal is what we call a proportion, if we're talking statistically speaking, and a proportion is always out of 1. 0.31 is saying 0.31 of every one item has whatever quality we're focusing on. A percent is always out of 100. So to change that, I have to multiply by 100. 1 times 100 is 100. So I have to multiply the numerator by 100 as well. 0.31 times 100 is 31. So 31 out of 100, which is 31%. Now, if I'm going to multiply by 100 each time here, which I do because I have to go from out of 1 to out of 100 each time, all that's going to happen is the decimal point is going to move back 2 spots to the right. So if I have 0.78, what's that going to come as a percent? 78. I heard somebody whisper. Good. 78%. How about 0.2? What's that become as a percent? 20%. 3.6. What's that become as a percent? 360%. 0.04? 4%. Good. Changing a fraction into a percent. Let's start out with one that we all know. 3/4, of course, everybody knows that that is what percent? 75%. But if we didn't know that, how would we go about calculating it? Well, we could do 3/4, and we could divide it out. 3 divided by 4 is 0.75. We could divide out the fraction to make a decimal. We could move the decimal point to make it a percent, 75%. That will work. Sometimes it gets a little ugly because the decimal doesn't work out perfectly, but that will always work. I prefer to look at it this way. 3/4 can be thought of as a ratio, 3 out of 4. And a percent is always out of 100. So I need to change 3/4 to something out of 100. Now I could treat it like fractions and come up with what do I multiply the 4 by to turn it into 100 and do the same to the 3. And that works okay here, but in some problems that's a little tricky to do. Simpler thing to do is a process called cross multiply. So if I put x in there, I can cross multiply. 3 times 100 is 300. 4 times x is 4x. And those have to equal each other. Now we haven't done any equations yet. That's going to come in the next unit. 4x equals 300. To solve that, we would divide by 4. So x equals 75. So 75 out of 100 is 75%. Now, since these are simple proportions, there's a shortcut. If I'm just trying to find one missing number, like I am here, the x, I don't have to cross multiply and solve the equation. I can just simply cross multiply. Multiply the two numbers that are on the diagonal of each other. So 3 times 100 is 300. And then divide by the number that's by itself on the other diagonal. So divide by 4. 300 divided by 4 is the 75. So if I have 7/8, it's going to turn that into a percent. What's out of 100? Now again, if I try to do it as fractions, what do I multiply 8 by to get 100? That's a little trickier to do. So I'm just going to do 7 times 100 is 700. Divided by the 8 is 87.5. So 87.5 out of 100 is 87.5%. Next, I want to take a look at calculating percents. But remember, we mentioned benchmarks. So we're going to start out by looking at benchmarks. I'm going to give you the number 2,800. Nice round number to work with. Common benchmarks that are easy to calculate are 10%. 10%, of course, is 10 out of 100, or 1/10. So that implies 10% is just 1/10 of the number. So for 2,800, 10%, what's going to be 1/10 of that? Well, the easy way to find 10% is move the decimal point over one spot. 280 is 10% of 2,800. Another pretty simple benchmark is 1%. 1% is 1 out of 100. What would 1% of 2,800 be? Well, 1/100th means you divide by 100. In other words, you're moving the decimal over 2 spots. So that would be 28. Now, even with just those two very simple percents, those simple benchmarks, if I were asked to find %, of 2,800 or 2,800. 21%, I'm going to break down into 10% plus 10% plus 1%. That adds up to 21%. Well, 10% is 280. Another 10% is 280. 1% is 28. Adding that up, I get 588. So 21% of 2,800 is 588. We haven't seen a thing about how we actually calculate with the percents yet, but we were actually able to calculate 21 is not a simple percent. Now, there are other benchmarks we can talk about. Another one of them we might mention would be 50%. 50% is 50 out of 100, or 1/2. So 50% or 1/2 is easy with some numbers if you can simply divide by 2. 2,800 divided by 2 is 1,400. So I can find 50% of the 2,800 pretty quickly. Another one is 5%. 5% can be thought of in a couple of different ways. One approach to 5% might be, say it's half of 10%. So you say 10% is 280. Half of that is 140. That's 5%. The other possible way of looking at it is it's 1/10 of 50%. In other words, I can take 50% and move the decimal over one spot. Well, 50% is 1,400. Moving the decimal over one spot is 140. So those are two different ways I could go about finding 5%. So let's say we were asked to find let's do 65% of 2,800. Well, again, I'm going to break that 60% down. I'm going to put it as a 50%, a 10%, and a 5%. I can find 50% really easy. That's half. It's 1,400. 10%, move the decimal over one. That's 280. And 5%, either it's take the 50%, move the decimal over, or take half of the 10%. Either way, it gives me 140. And I just add them up. 0, 12, carry the 1, 5, 7, 8. 1,820. 1,820 is 65% of 2,800. Now, I gave you a nice round number here with the 2,800. You're not always going to have it that easily. So really what I'm talking about here is just finding an estimate. If I ask you to find 49% of 793. Well, we're going to do that exact calculation with a formula and a calculator that we're going to look at on Friday. For right now, though, if I wanted to estimate that, I would look at that and say, well, that is about 49%. That's 49% of something that is about 800. 49%. Now, I don't have to just add percents. I can actually do this. I can say that's 50% minus 1%. Well, 50% is half of 800 would be 400. Minus 1% of 800 would be 8. I'm expecting something about 392 in my answer. Now, the actual 49% of 793 is going to come out to 388.57. So when we get that answer on our calculator, we have this estimate to compare to that tells us, yeah, that's really close. It sounds about right. Just like we talked about when we were adding, subtracting, multiplying, dividing whole numbers. I understand that you're going to use your calculator when you can, but have that estimate in the back of your mind so you know if something went really, really wrong on the calculator. Okay, so on Friday we will pick up talking more about percents. We're going to look at the calculations with percents. We're going to look at percent increase and decrease. And we're going to look at some interest applications, depending on how much time we have. Then on Monday, we will wrap up Unit 1. So that'll be dealing with some Roman numerals and some other things to wrap up the unit. Each of those 2 days, we'll do a little bit of review because, as I mentioned, there is the first portion of your test you cannot use the calculator on. There's actually a little note down there that says where you can start using the calculator. Now, by not using the calculator, I don't mean that you can't touch your calculator. You can use the calculator to double check your answers, but when it says no calculator, I mean, you have to show your work. You have to show the steps to do the calculation. Okay, so there is a page in the homework you can start on. We didn't do all of this today, but you can get a start on page 36 through 37 out of the book. 1 through 51, the odds cover all of it. You're probably looking at just the first portion of that. Like I said, we'll finish up with percents on Friday. So I'll give you guys our last 2 minutes here to go ahead and get started on the homework if you'd like.